Welcome back, and we're going to use our knowledge of other common functions to talk about piecewise defined functions. And these are, well, functions that are defined in pieces. So these actually pop up all over the place in the physical science world because sometimes the model or the physical quantity we model changes over or at different points in time or just based on a given input. Okay, and so piecewise defined functions really have this form where the entire thing is defined as a collection of individual functions, and then there's a domain. Again, so these are domains. These are indicating when the function is valid. Okay, so again, this is just two pieces, but you can have 3, 4, 5, 22. Okay, you can have many different pieces here. Okay, so let's look at an example and try and graph this example. So I'm going to have to make, just due to space, I'm going to have to make a smaller grid here. Okay, so I'm going to label X and Y, and then I want to, let's see, it looks like the X values I need to pay attention to are -2, and maybe I'll make those just a little bit more spread out. So let's do -2 like that, and then 1, 2, okay. I'll worry about the vertical axis in a moment, but what we know, I'm going to extend this way just a smidge. Okay, so what we know is that when x is less than -2, so that is to say, okay, so this is -2 and over this way, right, it's behaving like the function x plus 1. So then, for example, if x is -3, right, if x is -3, then what is the y value I get? -2. So -2, or -3, -2, so I would have this point. And at -4, it would be at -3. Okay, and then at 2, it would, or at -2, I'd have -1, so I'd actually have a hole here, because again I don't have equality. So this is kind of what the first piece looks like, and it would extend forever to the left based on this pattern because of this domain. It's saying when x is less than -2. Okay, so that's the first piece. Now for the second piece, it says it's behaving like x cubed between these values. So really what we see is that, okay, between -2 and +1, I know there's a 0, and 0 cubed is 0. Okay, at -1, if I put that in here, I get -1, -1. Okay, and at -2, I'd be all the way down there at 8, so I'm just going to say, like, here's -8 on my scale, and then it'll be down something like this. And so really the next piece is a cubic graph. It's just going to look something like this. And the reason I have a hole at 1, 1 is because, again, I don't have equality here. So really, to summarize, what I'm doing is I'm graphing the function x plus 1 for these values of x. Then I progress and graph the x cubed function in this domain, and then the last one is going to look like a parabola. So again, if x is greater than -1, so if I put in 1, I get 0, and then from here it's going to look like a parabola that opens down. I'm not going to spend the time to finish the graph, but that's what it would look like, something like that. So you have 3 different pieces, and together they would form a function because they pass the vertical line test. So again, if you're looking kind of like right here, this would be an instance of concern, but it ends up passing the vertical line test because the hole means the value is excluded and the dot means it is included. Okay, so we can ask you to take a function, produce its graph, but we can also go backwards, right? So this is a bit of a more challenging feat. If you get f of x is equal to, there's going to be 2 pieces, and it looks like there's this first piece here and the second piece here. So it looks like it splits, like the domain there'd be a piece that applies when x is less than 0, and then another piece when x is bigger than 0, or maybe even equal. And here in this first piece, this looks a lot like that 1 over x function. Now, how do I know it is that function exactly? Well, I don't, but I know the general shape, and I could test a point. So what I can see here is that this point is -1, -1. So if I happen to take and substitute in -1 in for x, do I get -1 for y? Yeah, I do. So this ends up working. So that seems to work for this first piece. For the second piece, that looks a lot like our square root function. Okay, so now this is this going to work? So let's take a test point. I have, let's see, this point, and let's see, this point is actually pretty nice too. Let's do that one. So that's 1, 2. So if I put in 1, do I get out 2? No, I don't. But if I add 1, I think that works. Is that consistent with this point, 0, 1? If I put in 0, do I get 1? Yep. So this seems to work for this one. All right. So I think piecewise functions, really, it's no different than graphing functions individually, right? But now we have just multiple functions all packed in one. That's the idea of a piecewise function. So the quiz question here is going to look at, or is going to give you a piecewise function and ask you to evaluate. I can't ask you to graph just because it, well, it isn't conducive to multiple choice selection. So take a shot at the quiz question.